So you can write the rest. Now we'll go to second definition. Because some of the compounds which doesn't have OH minus, like ammonia, will still act as a base. So we need an explanation for that. So that's why Bronsted Lowry come up with a different definition. They are two different scientists. They said acids will donate a proton. Acids will donate a proton. So what is a proton is? We know that hydrogen has one proton and electron. Okay, one proton and electron. After losing that electron, hydrogen will become a proton. That's why we are calling it proton. And it will like this, HCl split into H plus and Cl minus. And they said bases will do what? Bases will accept that proton. Say for example ammonia will accept NH plus and form NH4 plus, which is the famous ammonium ion. So here you can see there are two compounds, both are starting with the hydrogen, both can donate, but we know that sulfuric acid is the strongest acid compared to water. So water will act as a base and acid will be acid. Which reactant above lost or donated hydrogen? We would go right H2SO4. After donating hydrogen, it will form what? HSO4 minus. The reason, let me erase this. The reason it is removing one hydrogen and a proton, that's why it is become negatively charged. So these are related because H2SO4 and HSO4 has only difference in one H plus ion. That is called conjugate pairs. So we will call this negative ion a conjugate base. Reason why we call, if you reverse a reaction, like if you go this way, HSO4 minus and H3O plus, then HSO4 will gain the proton and form H2SO4 and water. So that is gaining the proton, so that's why it is a base there. So we will go right, this is a conjugate base. Same thing, water, after gaining a hydrogen, it will form hydronium ion, and that is called a conjugate acid. Same thing, you are going to write that reaction here. Okay, let's practice. So there are two compounds starting with the hydrogen. One is water, so I will go write water as a base. This is an acid. After removing this hydrogen, it will form NO3 minus. So that is called the conjugate base. And this is after gaining H, it will form a conjugate acid. Okay, another example, this will be a base, this will be acid, and I'm going to write the abbreviation Ca for conjugate acid and Cb for conjugate base. So this will be the conjugate base and this will be the conjugate acid, because conjugate acid and its base, or conjugate base and its acid, they differs in one proton. That's how you are identified. Okay, so then Lewis acid definition. So after the second definition also, there are some compounds with acidic properties which doesn't cover all this definition. Then the famous Lewis, we know that Lewis dot structure we learned. He said electron deficient compounds like BCl3, when you draw the electron dot structure for BCl3, we know that it has 3 bonds. That means it has only 6 electrons in the central atom, and stability comes only with 8 electron. So that type of compounds which are loving electron, or not loving, that's another name, okay, electrophile, it's like needed an electron, so we will say electron deficient compound. So Lewis acid will be compounds like that, they will accept an electron pair, and bases will donate an electron pair. Say for example, if BCl3 reacts with ammonia which has a pair of electron, BCl3 will accept that electron pair and they will form a complex. Say for another one, hydrogen ion no electron, so it will accept electron, and ammonia has two lone pairs, so it will donate electron and it will form hydronium ion. Okay, that is that. So you can write acids, Lewis acids, like all group 3 B covalent molecule, BlCl3, BF3, AlCl3, all of those are electron deficient, and maybe hydrogen ion, any electron deficient ions also. And bases, Lewis bases, anything with lone pair, ammonia, water, cyanide ion, OH minus, all of these are Lewis bases. Okay, now let's do practice. I will do one question each from all of this. You have to do the rest, okay? Okay, let's start. So it says you had to write the conjugate base of the following. That means all of them is considered as acid. So ammonia, after removing one hydrogen, it will form NH2 minus and H plus. But that is a rare condition. Ammonia will very rarely act as an acid. So I'm going to change this one into a base, okay? Okay, if it is a base, it will accept an electron and form NH4 plus. So if it is an acid, it will remove a hydrogen, it's not electron, hydrogen. So this will form H3O. After removing this will form SO3, SO3 2 minus. NH4 will form NH3, HPO4 minus 2. Okay, then you are going to write conjugate acid of from the following bases. So all of them are bases. That means they all accept H. So it will form HPO4 minus 2. And the last one, we may confused how to write. It's an alcohol. Alcohol has a structure like this with lone pair on oxygen. So this is the place they are gaining hydrogen. So that will become CH3OH2 plus. So all of them are conjugate acid now. You can write Ca. Okay, next one. This is an acid. This is a base. So it will donate electron. It says only one at a time, so it will be minus and it will be plus. So this is conjugate base and this is conjugate acid. And you are going to identify conjugate acid base pair. We know that they differs only in one H plus ion. There is no hydrogen, there is no hydrogen. This one has a hydrogen difference, but oxygen is missing, so no, only the last one. And here, so here this is an organic compound, so you may confused about whether it is an acid or base, but you have to look at the right hand side. What happened? It gained a proton. Gained a proton means it is a base. This is an acid, so this will be conjugate acid and this will be a conjugate base. Okay, same thing with this. This is lost an hydrogen, so this will be an acid. This is base, then conjugate base, conjugate acid. So here you have to write conjugate acid, so it will be H2O, add one hydrogen, this will be HCO3 minus, like that. To write conjugate base, that means it is losing one hydrogen, so it will be HSO4 minus. And here same thing, so both are starting with hydrogen, so water will be base, this will be acid, this is conjugate acid, this will be conjugate base. And for this ones, you have to write the conjugate acid base, then write whether it is ion or molecule, and then identify whether the reaction is explained by Arrhenius. Arrhenius means donating hydrogen and accept donating OH minus. This one, the reaction you can explain by Bronsted-Lowry because it is donating hydrogen and accepting hydrogen. Okay, now the last page is a one-page review. You have to answer all of this. If it is acid, write A. If it is base, write B, like that. Then copy the notes from the previous pages. Definition for Arrhenius acid, Arrhenius base, Bronsted-Lowry acid base, Lewis acid base. Then write the examples for strong and weak acids, all of that.